Hello everyone, in this video we will show you how offloading communication protocols like TCP or UDP to the latest FPGA board from Altera, Agilex 5 Sulfur can reduce CPU load and increase throughput, enhancing your CPU performance. Then, at the second half of this video, we will show you a live demo and the very satisfying results. First, let's talk about application this day. We normally use internet speed of around 1 gigabit per second for video calls, web browsing, or gaming. But high-speed computing needs even faster internet. We step up to 10 gigabit per second for applications like AI computing, cloud computing, or 8K file transfers. And that's gonna cause us some problems. The communication protocols we use for all these tasks are TCP or UDP. First, TCP is used when reliability is a concern, and for sensitive data that requires error correction, such as web browsing or radar. For UDP, the focus is on speed and real-time applications that do not need error checking, like game streaming or broadcasting. At 1 gigabit per second, the CPU can handle protocol and application processing. By the way, it is nearly overloaded, causing throughput to remain around 70% or 700 megabit per second. The problem happens when using 10 gigabit per second. The CPU becomes overloaded because the workload from application increased significantly compared to 1 gigabit per second. As a result, the achieved throughput is much lower than 10 gigabit per second, reaching only around 30%. The solution to this problem is to offload the UDP or TCP processing to an FPGA board. By using design gateway soft IP, the CPU load is reduced, making it run more efficiently and allowing the throughput to reach maximum bandwidth at 10 gigabit per second. This is the key advantage of our soft IP, which comes with in-depth documentation for seamless integration with your system. The FPGA we use to solve this problem is the Agilex 5 Sulfur, the latest FPGA board from Altera. It comes with free built-in hard IP, and when combined with our soft IP from Design Gateway, it can fix CPU overload and low throughput issues, providing a complete solution. Now, we will show you the demo of the process and result. To set up the FPGA and PC, follow these steps. First, connect the Ethernet cable between the FPGA board and the PC. Then, connect the USB blaster to download cable to both the FPGA and the PC. Finally, connect the power cable to the FPGA board and turn on the switch. This is the sending data demo. This demo will show you how the data is sent from the FPGA to the PC. After setting up the IP and data port in the NIOS command shell, enter number 2 for the send data test, then specify the data size and packet size you want to send. Next, type the command shown in the NIOS command shell into the command prompt, which the directory is where the UDP data test file is located. Once the program has finished running, the result will show that we have achieved full bandwidth speed, which is 10 gigabit per second. Now is the receiving data demo. The step will be similar to those in the sending data demo. We will enter number 3 for the receiving data test. The data size will be the same, which is 4 GB, and data verification will be enabled. Then follow the same steps, and the result will be as expected. As you have seen, offloading the UDP or TCP protocols to the Agilex 5 Sulfur and using the side gateway's IP core instead of letting the CPU handle them allows the throughput to reach full 10 gigabit per second bandwidth. Moreover, it reduces power consumption and enables CPU to run at maximum efficiency. That's all for the video. Thank you for watching and please stay tuned for our next video.